8567. Which of the following, obtained during magneto check at 1,700 revolutions per minute, indicates a short, grounded circuit between the right magneto primary and the ignition switch? A. Both, 700 revolutions per minute. R. 1625 RPM. L. 1700 RPM. Off, 625 revolutions per minute. B. Both, 1,700 revolutions per minute. R. 0 RPM. L. 1700 RPM. Off, 0 revolutions per minute. C. Both, 700 revolutions per minute. R. 0 RPM. L. 1675 RPM. Off, 0 revolutions per minute. The correct answer is B. A magneto check at 1,700 revolutions per minute that indicates a short, grounded circuit between the right magneto primary and the ignition switch would be shown as both 1,700 revolutions per minute, R, 0 RPM, L, 1,700 RPM, off, 0 revolutions per minute. In this scenario, when the ignition switch is turned off, the right magneto primary circuit should be interrupted, resulting in a drop in RPM for the right magneto to 0. However, if the right magneto primary is shorted to the ignition switch, the right magneto will continue to fire, and the RPM will not drop when the switch is turned off. 8568. If an aircraft ignition switch is turned off and the engine continues to run normally, the trouble is probably caused by A. An open ground lead in the magneto. B. Arcing magneto breaker points. C. Primary lead grounding. The correct answer is A. If an aircraft ignition switch is turned off and the engine continues to run normally, the trouble is probably caused by an open ground lead in the magneto. The ignition switch is responsible for grounding the magneto's primary circuit, which interrupts the flow of electricity and stops the ignition process. If the engine continues to run normally after the ignition switch is turned off, it suggests that the ground lead in the magneto is open or disconnected, allowing the magneto to remain operational. 8569. Which statement is correct regarding the ignition system of a turbine engine? A. The system is normally de-energized as soon as the engine starts. B. Lead is energized during the starting and warm-up periods only. C. The system generally includes a polar inductor-type magneto. The correct answer is A. In turbine engines, the ignition system is typically designed to ignite the fuel-air mixture during the starting process and for relighting purposes if needed. Once the engine is running and stable, the ignition system is usually de-energized, as the continuous combustion is sustained by the high temperature and pressure in the combustion chamber. 8570. When the ignition switch of a single, reciprocating engine aircraft is turned to the OFF position. A. The primary circuits of both magnetos are grounded. B. The secondary circuits of both magnetos are opened. C. All circuits are automatically opened. The correct answer is A. When the ignition switch of a single, reciprocating engine aircraft is turned to the OFF position, the primary circuits of both magnetos are grounded. This means that the ignition system is effectively disabled, preventing sparks from being generated in the spark plugs. 8571. A spark plug's heat range is the result of A. The area of the plug exposed to the cooling airstream. B. Its ability to transfer heat from the firing end of the spark plug to the cylinder head. C. The heat intensity of the spark. The correct answer is B. A spark plug's heat range is determined by its ability to transfer heat from the firing end of the spark plug to the cylinder head. The heat range is not related to the cooling airstream or the heat intensity of the spark. A spark plug with a higher heat range can dissipate more heat, making it suitable for engines with higher operating temperatures or higher power outputs.